Hello, we are Group 7 and our project is on Digital Supply Chain Twin. Group members are Aparna, Xiaohe, Malcolm, Weston, and Mufadal.
Here is the overview of our presentation. So we'll start with the introduction of the digital twin, then we'll explain the purpose and then functions and features of the digital twin. And then we'll see how digital twin is constructed. And then we'll move on to its applications and successful implementations. And then finally, we'll look into challenges, opportunities, benefits, and the recommendations for the supply chain managers.
The purpose of Supply Chain Digital Twin is to create a virtual replica or simulation of a real-life supply chain. It will utilize historical data and analytics from the business's real supply chain. A digital twin will simulate the intricacies of an actual supply chain, tracking inventory and modeling process flows in real time. With the help of artificial intelligence, you can monitor the supply chain and feed it data to make data-driven decisions by optimizing the model, monitoring efficiency, and flagging discrepancies. The overall purpose of inventing a digital twin is to create a modernized way to track and monitor your supply chain, enabling the business to theoretically digitally monitor a simulation of a supply chain in real time. The design goals are to simulate an accurate enough model to optimize transportation flows, information modeling, and then in turn create a more efficient supply chain management system. With these changes and additional features, a digital twin will optimize the supply chain. Large upfront financial investment is required to create a supply chain digital twin because of the initial time investment of developers and engineers, which will lead to gathering resources, collecting data, and implementing features. To create an accurate high-fidelity model is a tedious process and requires a team of full-time developers to create a digital twin. Startup and development will then eventually continue to require extended upkeep and maintenance of the virtual model. Initial investments require copious amounts of data to implement to the digital twin to try to train artificial intelligence. In order to create a digital twin with a high-fidelity model, and high digital accuracy will require large volumes of processing power and graphical processing power. Functions and features of a digital twin. Part of the features of a digital twin is the ability to create a virtual model of a physical supply chain. This model creates a unified view for illustration purposes, simplifying a viewpoint of a somewhat unknown system to some of the stakeholders. Creating a centralized system to monitor and track supply chain changes will help provide clarity for modifying process flows and inventory policies. Having artificial intelligence monitoring the system can be helpful for catching system failures or even scheduling preventative maintenance throughout the day cycle.
Now, let us look into how a digital twin is constructed. Building a digital twin of a supply chain is a complex process, which requires high attention to details and expertise. While going through various researches, we identified there are 7 steps for the construction of the digital twin. So the first is defining the objective, which is the critical part of the construction. Here we identify the problem of the business which is to be solved. So the problems such as optimizing the inventory management, reducing the lead times, or improving the demand forecasting. Here, the teams responsible at each aspect of the supply chain, such as transportation, warehousing, inventory management, sourcing, etc., should collaborate to outline the processes and assets that will be replicated digitally. The next step here is collecting data from various relevant sources, including suppliers, logistic providers, and internal systems. The data used here is comprehensive and is updated in real time to ensure that the twin accurately reflects the current state of the supply chain. It is commonly integrated with Internet of Things. The third step here is integrating the collected data into a single platform. It requires consolidating the data from different sources, cleaning, standardizing the data, and ensuring that the data is accurate and consistent. This architecture should enable connections to various data sources such as internal, external, and real-time data and be able to handle diverse data formats. Additionally, the architecture should be scalable to support the multiple simulation and optimization scenarios. So here the security and monitoring should be configured to provide convenient access to users with distinct purposes and responsibilities. So as it is visible in this picture, the data is collected from various sources, and then it is pre-processed and cleaned in a system, and then it is visualized using various tools, and then further it is integrated for the use in digital twin. So the integrated data in the step 3 is now used to develop the digital twin. This step involves creating a virtual representation of the physical supply chain, including different nodes, flows, and processes. As visible in the picture, it is an example of a digital twin that affects the various aspects of a supply chain, including maintenance, repair costs, then testing, logistics, and the customers. So it almost includes all the aspects of the supply chain that affects the stages of the supply chain. Now, when constructing a digital twin, it is crucial to have a long-term perspective. The framework should enable simulation and analysis of processes and prediction of the events. Now, the next step is its validation. Validation involves comparing its output with the real-world data. So, testing the digital twin's ability to accurately predict the supply chain performance and identifying if there is any discrepancies. The next step is using the digital twin. Digital supply chain twin present opportunities for predictive and advanced analytics, which can help in decisions at both strategic and operations level. The output here should be shared throughout the organization to promote organization-wide action plans. And finally, continuously updating the digital twin with new data and insights is an ongoing process that requires incorporating new data sources, monitoring the supply chain performance, and adjusting the digital twin as needed to ensure that it accurately reflects the current state of the supply chain.
Okay, let's look at the first successful case here, the BMW and NVIDIA. So before digital supply chain came out, the problem many industrial giants faced was that they needed help to predict the potential problems in their plants before they had built them. And Omniverse can be simply understood as a model of a virtual world, a 3D one-to-one virtual factory. And designers can add various machine, production lines, and factory buildings to this model. All robots in real life have corresponding 3D models in this virtual world. They are affected by gravity, have solid body, movable joints, and real collision volumes. And for the virtual Singapore, their data is sourced from satellite data and airplane with laser scanning of the city ground. It can improve sustainability efforts, analyze on potential for solar energy production, urban planning, and population growth.
There are 3 key challenges that we identified with digital supply chain twins. 1 is maintaining real-time data transfer, 2 is maintaining accuracy and reliability with the simulation modeling, and 3 is managing the significant costs associated with artificial intelligence monitoring. With the first, we know that there can be multiple sources of truth across a global supply chain and multiple systems to manage, and that can make it difficult to ensure that there is accurate and reliable real-time data transfer into the digital supply chain. This also translates into challenges ensuring the accuracy and reliability of the simulation modeling. We know that if you put garbage in, you get garbage out, and the model is only as accurate as the information going into it, and only as helpful as the analysis of it. Lastly, training artificial intelligence requires significant database preparation or pre-processing, which has significant costs and can be a significant upfront cost for a business.
There are many opportunities that come with digital supply chain twin. First off, integration with other predictive analytical tools can provide an even higher fidelity model of your supply chain and thus create better predictions. Secondly, there is potential to remotely control your supply chain's operations through the digital twin via integration with your command and control elements. Finally, it can be used to stress test your supply chains for events such as massive disruptions to transportation, supply, or large spikes and drops in your demand. There are many benefits to digital supply chain twin. First off, the virtual replica can be very useful for illustration purposes, particularly when computational power allows for highly detailed graphical models. As well, it provides a deeper level of analysis than a simpler simulation model because it has more accurate and continuously updated data inputs and parameters. And of course, this aids in tactical and strategic level planning for your supply chain. Overall, digital supply chain twins provide better prediction capabilities, and because of this, can increase your supply chain's agility. We have several recommendations for supply chain managers with regards to digital supply chain twins. So first off, supply chain managers should implement a digital twin where ordinary simulations don't provide enough detailed or accurate information for their purposes. Supply chain managers can use it to monitor, test changes, and forecast for the model supply chain. However, they must ensure that they continuously update and review the digital twin so it stays accurate to the changing present and future. And of course, they need to monitor future developments within the field, especially as it relates to machine learning and AI and how that can be incorporated into digital supply chain twins.
Here are few references we used while researching for the topic of our project.
That's all we have. Thank you very much, and we'll take any questions now.